to join. Yeah, good evening, Professor Gettu.
Evening.
We had circulated a sheet for responses or for you to actually put your questions there, but it looks like there's only one question that has been received. What will be the design and analysis consideration that will be adopted in terms of codal provisions, such as IS 456 values of dead load and live load? I think Madhav, you're on anyway available here, right? I thought I saw Madhav. Yeah.
Yeah, he's there.
Yeah. Can you?
Yeah, Madhav Bardwaj. Yeah, can you clarify the question?
Yeah.
Madhav, you have to unmute. Yeah, can you unmute?
Yeah, can you unmute and then clarify what you've asked, because we are not able to figure out what is it in context with. Oh, he can't unmute. He's
You're in library.
Okay, fine.
Well, the code will tell how much live load and dead load to use, no? So this will not change by the type of concrete. It will not change.
Yeah.
Right, Manu?
I presume he wanted to understand if when recycled concrete is used, if there's any change in the, because all of our topics were on recycled concrete. Yeah. So I presume that his question was, when recycled concrete is used, will there be any change in the design of slabs and beams? See, again, we are only dealing with concrete. Designs will not change.
Yeah, design.
We're only dealing with the material, which is different.
Any other question?
Yeah, people who've joined online, kindly unmute and ask your question if you have to.
Good evening, sir. Janardhan here.
Good evening.
Sir, is there any practically in India, they've started already making concrete out of it? Like in the classes, we saw like in Indore, in Bangalore, there are many plants. Is it practically like 30% or 25%? Any project they are done like that? Any case studies are there?
See, the projects that are there are in the vicinity of wherever these recycling plants have been set up. So Delhi has several projects in which recycled concrete has been used. Bangalore also, because that's where the plants are available. And the code already has a provision, obviously, of utilizing part of your aggregate as recycled material. So from that perspective, the projects that are in and around those plants have been utilizing the recycled material. Unfortunately, when the distance becomes too large, it becomes uneconomical to use the recycled material.
That is about like 20%, sir, they've used?
Yeah, so up to 20% utilization is possible for concrete of grades M25 and below when it's coming to when it comes to reinforced concrete. For lean concrete and for concrete which is intended for the PCC layers that are underneath regular RC rafts, you can actually go with 100% also.
Oh, great, sir. Great. Thank you, sir.
Lot of the recycled material is used for fill and sub-base and subgrade in pavements. This internationally, that seems to be the widest practice, to replace natural soil and rock to use as sub-base and subgrade and filling.
Ravindra, you can give an example of our own building where we did this.
Yeah, so thanks, Manu. So we recently demolished a small building that we had on campus, and this was made out of hollow blocks, walls, and it had plastering and it had reinforced concrete roof. So we demolished completely. We removed all the things that had salvage value, like the windows, doors, and the steel was also taken and removed. All the remaining was crushed. We tried to crush to as small as possible, 5 centimeter and less sizes. And this was mixed with soil and put back in fill in the building that was constructed newly in the same location. So almost everything that we got from crushing has been recycled. So actually nothing left our campus in this particular case. And we are hoping that this will continue on our campus, and demolition waste will not leave the campus, but we will be able to reuse. So in this case, we did not get any new material from outside campus for the filling. We just use the excavation soil and we mix it with the demolition waste and we used it to fill again. So that is one application which is very much possible wherever that there is demolition and reconstruction.
And I think one of the lectures also, some details on mobile crushing facilities were also provided. So whenever there's demolition, taking a mobile crusher, getting it crushed over there and reutilized in the fashion that Professor Gettu just talked about, I think that would be an ideal way to utilize it.
Absolutely, sir. Absolutely. Maximum grade M25 we can do it, sir, comfortably.
As per IS 383 currently, that is the maximum grade permitted. However, we are also interacting a lot with the IS 383 group to ensure that we are able to push for slightly higher grades also, like 30 and 35 MPa, because that's where the bulk of the concreting in urban areas is concentrated on. So if we cover 30 and 35 grades, definitely we'll be able to utilize much more of this material.
So by any chance, any compatibility issues we have faced in any of the projects or even abroad also? So the M25, I think it's possible. In abroad, what is the maximum grade we can make, like they are successful? And is there any compatibility issues they had come
in
across?
Research, people have done even for 50, 60 MPa grades. Depends on the type of concrete that you're crushing, the extent of the aggregate component inside the concrete and so on. People have gone even as high as 50, 60 MPa.
Okay.
Yeah. But since the experience with recycled materials is not very large in India, we are obviously a lot more conservative at this stage.
Okay, sir. Thank you, sir. Thank you very much.
I think that answers also the question of Madhav. He was asking about large projects. So depends on the grade and the type of parent concrete also.
Correct.
Smita, you have a question?
To what extent can we use recycled aggregates in geopolymer concrete? Again, there is no specific code on that. Right now, of course, geopolymer concrete is also mostly experimental. I mean, there are no codes yet on geopolymer concrete. So nothing stops you from utilizing as much as you want at this stage, as long as you have the engineering data available for the concrete that is produced with recycled aggregate and geopolymer. Okay, there's another question. How feasible is the use of recycled concrete aggregates in structural concrete, and what are the current challenges or limitations in adopting it widely in the construction industry? Of course, this is the content which we have covered in a big way inside the lectures. But maybe Ravindra, you want to just give a brief response to that?
Yeah, see, it depends a lot on the quality of your demolition waste. If it is purely concrete, then it's easier to recycle. But usually, demolition waste will have bricks, will have plastering, will have gypsum and so on. That makes it more complicated. So segregation is very, very important. If you can segregate the waste, it makes it easier to adopt it. Now, the question is, what is the strength of the original concrete? If you know where it came from, like one of the projects we had discussed was in the Chennai Metro, you know that it is 50 megapascal concrete. So when you're crushing, it's all uniform, same grade. Then it's easier to use it. So if you have 50 megapascal concrete as a parent concrete, easily you can make M25. That's not a problem. No, but if it is a mix, then it becomes more difficult. So these are, I think, the same challenges and limitations everywhere. How to segregate, how to know what is the strength of the aggregates when we are using. Same as if you are using random aggregates, it is the same issue. Suppose you don't have regular granite aggregate and you are going to look around for what aggregate to use. Same challenges will be there for recycle also. The additional challenge is regular aggregates come from a quarry where there is crushing or collection. Here, demolition happens in different places, scattered, irregular way, they'll be dumping. So that is a bigger challenge. How to collect all this, how to know what has been put, and how to separate, clean and mix and bring it out. So unless that is regulated, it will always be difficult. So the countries which are doing well are countries like Germany, that Professor Manu recently visited, or Switzerland, where there is a regulation that you have to separate. So they cannot mix and they segregate and give it, and it's easier. And also countries or cities where it's compulsory to recycle some material, then there is more usage of the demolition waste. Again, about cost, yes, it is expensive, but suppose we have environmental taxation of pristine aggregates, like suppose all quarries will have to pay a very high tax, which might happen eventually when we run out of material, then your recycled material might become cheaper. This is what is happening in many countries. People have to pay a very high tax when they want to use new aggregates or pristine aggregates. Then what happens is the recycled aggregate becomes competitive. Right now, we don't have such regulation, so it is more expensive to recycle. But again, it's very heavily subsidized. Cities also want people to use recycled material. So part of the cost of the processing is being paid by the cities. So eventually it might have to be adopted. We may not have a choice of whether to adopt or not. There is some regulation already, and this might become more prevalent where in every project, we might have to use a certain percentage of recycled material. Then it will become more and more prevalent. But now it is more difficult to convince people and to make it cost effective.
Can concrete be designed to absorb CO2 and is it being used in real projects today? See, concrete does absorb CO2 because there is calcium hydroxide in concrete and other calcium-bearing phases which will interact with the CO2 that penetrates the concrete and convert to carbonate, more stable carbonate phases. So that happens with normal concrete also. Except, of course, when carbonation happens, we are essentially losing the alkalinity of the concrete and eventually corrosion can get initiated. So, but then when you're talking about plain concrete blocks, you can certainly absorb CO2. Now, that is a natural process, but you can also make it happen forcefully by utilizing a chamber where carbon dioxide concentration can be high enough and provide curing for the concrete in the presence of carbon dioxide, which is able to probably bind a little bit more CO2 than the natural process. Alternatively, people also try to alter the cementitious constituent and add something like lime or calcium hydroxide additionally to the concrete mixture to increase the carbon uptake capacity of the concrete. So all of these are practiced by a number of different startups that are all over the world now. They're talking a lot about CO2 sequestration, but you have to keep one thing in mind is that the extent of CO2 that you can absorb is limited by the chemistry of the system that you're considering. So it's not something that will be a sink for a lot of CO2. Maximum you can fix is probably restricted to about 5% of the total mass of the concrete. More than that will be quite difficult in concrete blocks to fix more CO2.
Also, another thing is when you don't have steel reinforcement, like now we are talking at least experimentally, about glass reinforcement, GFRP bars or textiles, their carbonation can actually become better because the cement mortar or the cement paste can actually attack glass. But when the pH drops, then this attack is reduced. So that could also be something that we can start looking at. We are doing some work here at IIT Madras, and this could be an opportunity also to look at non-ferritic, non-steel reinforcement. Not use steel reinforcement, use some other steel, some other reinforcement, and allow carbonation to happen.
Lifespan using recyclable concrete, I presume you mean recycled concrete aggregate. So as I said, we are just changing the aggregate phase. The concrete still has to satisfy certain minimum characteristics in terms of mechanical properties as well as durability properties, including the permeability of the concrete. And many of the life estimation models have some estimate of the permeability that they take to establish the life cycle of the structure. So as long as you can design the concrete to meet those permeability demands, I don't think there's any difference in the life of the structure that you'll get, whether you use natural aggregate or recycled concrete aggregate. So the methods of calculation will be the same. You'll still have to evaluate the same transport parameters like permeability, absorption, and so on, and the resistance to corrosion. Based on that, you can establish the service life just like you do for normal concrete. So we have other questions from the people who have just joined. 3D printed concrete. Okay, it's not a subject within our course, but okay. Is it a practical solution for sustainable construction in the near future? So all those words will not go together when you talk about 3D printed concrete. 3D printed concrete is definitely a good solution for producing some very nicely architectured concrete structures. But as far as being sustainable is concerned, because it uses a lot of cementitious material, currently this material is not sustainable, or at least it does not compare in terms of sustainability with normal concrete if you're considering it for normal structures. But if you're only looking at specialized structures which cannot be done easily with formwork, then certainly 3D printing has a future. And it may end up being more sustainable if you evaluate correctly the entire process for structures that really need the role of 3D printing. So all of you are hopefully preparing for the exam, because the exam is next week, right, Umesh? 26th.
Yes, sir.
Okay. Okay, there's a question on using sea sand as an alternative to desalinated river sand. Desalinated river sand. I'm not sure why you would need to desalinate river sand. But yeah, sea sand obviously will have a lot of salt in it. And the particle size characteristics also will differ a lot as compared to your river sand or even crushed stone sand. So you have to be careful about what you're getting in the sea sand. If you have to calculate the overall chloride load that it's bringing into the concrete, because overall your concrete needs to satisfy a certain maximum level of chloride inside, which is brought in by the ingredients. You can desalinate, but that process obviously is going to be very difficult and expensive as far as sea sand is concerned. But yes, if you have a practicable solution that that would be something that will work. But again, the particle size distribution also needs to be evaluated carefully, because the range of sizes that you see with river sand or crushed stone sand may not be possible with sea sand. Ravindra, would like to add something?
Yeah, so sea sand maybe can be used when you don't have reinforcement. Suppose you are doing paver blocks or even some building blocks, it's possible. But we'll have to make sure there is no leaching and the mix
Leaching
design
and
is properly
efflorescence
done.
could be issues that we have to look at.
Yeah. But if you don't care about it, it can be used. People have used it also. But
Correct.
the danger is the wrong usage.
Yeah.
Suppose you allow people to use it in one project, how do you make sure that it is not used in structural concrete? That, I think, is the reason why most code bodies will worry about it. Once you open it up, there can be wrong usage, and people can start using sea sand everywhere. So that is a big problem. So as long as you are very careful and you know where it is used and what is the effect of the salt, then it should be okay. Is there any utilization of ready-mix concrete sludge waste in India? It has been used. Even one of our students who is working with Professor Manu and me is looking at concrete sludge. So the advantage is that it is very high in the hydrated cement paste and fines. So if you are going to reuse it as fine material, it is quite easy. You will not have a lot of large aggregates in it, but for the fines, it can be a good source. So people have used it to as a fine material, as a filler. People have used it, and it looks like in some cases it can be activated and it can also be reactive.
Yeah, practical usage, I'm not sure if anything has started yet, but any other questions? Umesh, were there any questions in the forum that need to be addressed separately, or were you able to answer most of them?
Sir, mostly it is covered. I will see on the YouTube live if there are any questions, and then we can close.
Okay.
So there are no questions on actually YouTube.
Okay.
On forum also, they asked the basic questions about sometimes there was an error in their correction.
Okay.
Only.
Okay. All right. Okay. If there are no further questions, you can probably stop. Okay.
We can close. There are no other questions from anyone else. Shefali just joined. Shefali, any question?
Okay. Looks like
Yeah.
no more queries. So thank you all for joining, and all the best for the final exam. If you have any questions while you're preparing, please do send it through the forum. We'll try and answer all of them.
Thank you.
Thank you. Thank you all.